Okay, quadratic inequalities. I basically have the same question on both sides of the board here. However, on the left-hand side, the expression is greater than 0, and on the right-hand side, the expression is less than 0. I've made it the same questions to illustrate exactly the differences in the final solutions that we'll get. So step number 1 is going to be to factorize double brackets x minus 4, x minus 3, and this is greater than 0. Right hand side, the same thing, x minus 4, x minus 3, and this is just less than 0. The roots will be x equals 4, x equals 3, x equals 4, x equals 3. Okay, those roots will help me draw the graph. So I'll draw my axes now. This will cross at x equals 3, x equals 4, and same thing here, x equals 3, and x equals 4. Alright, now on the left hand side, this is greater than 0, so what I'm going to do is look at the graph and literally look at where is this graph above the x-axis, where is it greater than 0. So if I shade in these regions here, for these regions, it is above the x-axis and also in this region here. This region is basically whenever x is less than 3, to the left of 3, and this region here is to the right of 4, so whenever x is greater than 4. So these are my solutions to this quadratic inequality. X is less than 3, x is greater than 4. You'll notice that there are two separate and distinct inequalities, and that makes sense because we have two separate and distinct regions on this graph where this inequality is satisfied. Two separate regions, therefore two separate inequalities. Going to the right hand side now, where is this graph less than 0? Well, actually it's less than 0 below the x-axis, so it's less than 0 in this region here. That region can be described as everything rightwards of x equals 3 and leftwards of x equals 4. In other words, it's when 3 is less than x, which is less than 4. So that's our solution to this inequality on the right hand side, and it makes sense because by looking at the diagram, we have one collective region, therefore we have one collective inequality. And there we go.